Hi everyone, welcome to Manish IT. Today we are going to discuss about introduction of data structure using C language. So let us start. Data structure is not a language. Then we can say it. The data structure is the concept of set of algorithm used to structure the information. I already told that it is not a programming language like C, C++, Java and so on. It is set of algorithm means we are implementing algorithms using any programming language. For example, in C, C++, we have to write the program or our logic, but in Java language, they have given predefined implementation to do all these algorithms. So question is that what is data structure? Then simply we can say that to structure the information while storing, we note the importance of data storing for every application. Now our discussion is data structure means while storing the information. So what are the algorithms we should follow? If you follow those algorithms, then what will happen? And how effectively we are storing the information? All these are comes under data structure. So next, we have why need data structure. So first, what is data? So for its dictionary meaning is the quantity characters or symbols on which operations are performed by a computer, which may stored and transmitted in the form of electrical signals and recorded on magnetic, optical or mechanical recording media. So next, for example, we are here. I have given example like C equals to A plus B. A plus B is the data, and in between addition operation are performed, and C stores the addition of both data. So why when data becomes information? So how it's suppose we are giving some data like this is the data. This is not actual data, but just I have given here as example. So actual data having like some alphabets, number, digits, like and symbols and characters like that. There are maybe alphabets, anything may be possible, or combining of all these. So here this is the data, and we are getting some information from this data. Like the information is like my name is Manish. Suppose we are writing this data from left, from right to left, then we are getting some information. So from this aspects we are concluding like if data is arranged in the systematic way, then it gets a structure and becomes meaningful. This meaningful data is called information. So we can say like it means to provide an appropriate way to structure the data. We need to know about data structure. So next, introduction part of data structure. So data structure affects the design of both structural and functional aspects of program. Program is nothing but algorithm plus data structure. And second point is you know that algorithm is a step-by-step procedure to solve a particular function. That means algorithm is a set of instruction written to carry out certain tasks, and data is their logical relationship returned. And third is to develop a program of an algorithm, we should select an appropriate data structure for that algorithm. And last one is therefore algorithm and its associated data structure form a program. So what is data structure? So first point is data structure is the way of organizing all data items so it can be used efficiently. Second is data structure is a specialized format for organizing, processing, retrieving, and storing data. And third one is in computer programming, a data structure may be selected or designed to store the data for purpose of working on it with various algorithms. And data structure are widely used in almost every aspect of computer science, that is operating system, compiler design, artificial intelligence, graphics and many more. And it play a vital role in enhancing the performance of a software or a program as the main function of software to store and retrieve the user's data as fast as possible. So data structure mainly specifies the following four things. First is amount of memory required to store. Second, amount of time required to process. And third, representation of data in memory. And fourth one is operations performed on data. So here classification of data structure. Data structure is classified into two parts like primitive data structure and non-primitive data structure. Primitive data structure having nothing but it is predefined word. So here integer, character, float, pointers, and non-primitive data structure that is user defined. So array and list. Array having single dimension, two dimension, multi-dimension, and list having linear, non-linear, linear having stack, queue, linked list, non-linear having trees and graphs. So we will discuss it in next slide. So here what is primitive and non-primitive data structure? So first what is primitive data structure? So there are basic structure and directly operated upon by the machine instructions. In general, there are different representation on different computers. Integer, floats, pointer, characters, constant, string, etc. It is fall in this category. So non-primitive data structure is nothing but these all are derived from primitive data structure. And the non-primitive data structure emphasis on a structuring of the group of homogeneous. Homogeneous means similar type, or heterogeneous means different type. So homogeneous or heterogeneous data items. So in it, stack, queue, linked list, tree, graph are example for non-primitive data structure. And last one is the design and efficient data structures must takes operation to be performed on the data structure. So our common operations which are performed on data structure, which is first is insertion. Insertion means to add new element, and deletion. Deletion means to delete any element, and selection deals with accessing a particular data within data structure, and sorting arranging all data items in a data structure in particular order, and splitting partition single list to multiple list, merging combining data items of two different sorted lists into single sorted list, and traversing visiting each and every element of list in systematic manner. So first our discussion is stack. So what is a stack? You are getting some idea after seeing this. We will discuss in next video in details. So here we are giving I have given like brief information about it. So what is a stack? A stack is a linear data structure which works on LIFO order. LIFO is not nothing but it is last in first out. So here you can see that which element is going last, it comes first. Which element is going first, it comes first. So last in first out or first in first out. We last in last out. Here by mistake, oh sorry, here last in first out. Whatever is given entering here last in, it's come last in is this element and it comes first, and what which is going to first, then it comes last. So it works on the performance, it works on LIFO order, last in first out. So next point is, in a stack element it is always added from the top of position and removed from top of a stack. So next point is, initially top of a stack is initialized with -1, and next is a stack is useful in recursive function, calling function, mathematical expression, calculation, and reserving the string, etc. So next point, what are operation performed on a stack? So first operation is push, and second pop, third one pick, fourth one top, and fifth one traverse. These all are operation basic main or major operations of a stack. So we will discuss it in next video. So this in this we are giving like brief information about it. So next is queue. What is queue? So queue is nothing but queue is also linear data structure which works on FIFO order, like first in first out. So in this queue is always, suppose queue first in first out we discuss first 8. So here you can see here which here are there are like total number 6 members are there, and first members who are sitting we are who are in the counter, and whose member are nearest to the counter get serviced first. So it means like who are going to first, then they get first. So that's why its name is first in first out. So in second point, in queue element is always added at rear of queue and removed from queue from front of queue. So next is initially front and rear both are initialized with 0. Queue applications are in CPU scheduling, disk scheduling, IO buffers, and pipe, etc. And what are operations performed on queue? That is, first is NQ, second is DQ, and third one is front, fourth one is rear, and traverse. So these all are basic operations which are performed on queue. So we will discuss in next videos. So what is linked list? Linked list is nothing but it is a linear collection of elements in which linear order is not given by their physical placement in memory. So elements elements may be added in front or end of list as well as middle of list. So next point is linked list may be used for dynamic implementation of a stack and queue. So an element of linked list must contain at least two fields, one for storing data and another for storing address for next element. So see here there are two fields, data and next. Next is nothing but link, it stores address of this part, this data. So and head is pointed to first and null in the last linked part having nothing. So that's why it is the rule we have to provide, we have to put null in the linked list of last node. So next, for storing address we have a special data structure of list. The list address must be pointer type. So what are the operations performed on linked list? So first operation is insertion, second is deletion, third one is length of list, fourth one is traversing, and fifth one is swapping of list. So next, tree. So basically tree is non-linear data structure. So root value and subtree of children with parent node and represented as a set of linked node. So nodes can be added at any different nodes can be added any different node. So next point is like manipulating hierarchical data. So first point is like make information easy to search, second is manipulate sorted list of data, and third one is as workflow for composing digital images for visual effects, and fourth one is router algorithms. And the tree organization the data into branches which related to the information. So what are properties of tree? So basically root, left subtree, right subtree, child node, parent node, sibling, leaf node, internal node, number of edge, depth of node, height of node, like that. So now our discussion is going to graph. So what is graph is non-linear data structure and a set of items connected by edge. Each item is called a vertex. And the next one is formally a graph is a set of vertices and a binary relation between vertices and adjacent. So our graph applications are like first finding sorted routes and searching and social network connections and for internet routing. So if you having any question, then please comment in the comment box, and this video is really helpful to you, then please share it with your friends. So thank you for listening my presentation and watching. Please subscribe my channel.